Happy Friday, everybody. Welcome back to part two. I hope everybody had an awesome week last week. It seems like we just met yesterday, and here we are again meeting. So this week is going to be more in line with what we hope the next few sessions will be, where we're really going to spend time, hopefully with the discussion, question and answer. I see some questions already being asked. We would really like to have a discussion where we cover last week's notebook, which was this time happened to be the PST from notebook, where we're actually doing a lot of programmatic operations to wrap that existing Modflow 6 Freiburg model within the PEST interface and get ourselves ready to start to do some analyses. So I think we're going to split it up. Briak, you were going to go first.
Yeah.
So we've got a few questions. Do you want to cover those questions now, or should we wait till we come to those as we're going through them? I mean, I guess they're kind of about exploring the PEST interface. Should we discuss those first?
Yeah, I think we can.
Okay.
We can tick some of these ones off now, and then, at various stopping points as we go, if there are more questions, we can address them there. I would say and people can raise their hands as well if they want to. They don't want to get all smoky with their keyboard. They can raise their hands and someone will unmute and we can have a bit of a conversation as well. Cool. If you're feeling brave. So there's one question here from Vincent, really more around Modflow and FlowPy, but the difference between the simulation object and the model object that we call GWF. So that is, I think you've already had a go, or someone's already had a go at answering this. But yeah, that is part of the Modflow 6 modeling framework, that you can have multiple models associated with a simulation. So in most of these notebooks, I think we're working in Modflow 6 now, right? So you'll see that simulation object, which really is just an umbrella around specific model objects, and it's the model objects that most of the packages are attached to, and that's what we interact with most.
That's right.
Another one from Vincent: if PyEmu can run Modflow 6, why do we also need FlowPy? That's a good question. So we don't. There is most of the dependency within PyEmu for FlowPy is in the testing suite, because we use these Modflow models built with FlowPy and interacting with FlowPy within the testing suite. But most of what's in PyEmu now should be sitting outside of that testing suite, should be sitting outside of a FlowPy dependency. There are a few bits of FlowPy that we've borrowed around the spatial referencing, and that's kind of a bit of ongoing work for us as well. It's how we best deal with not relying on that dependency, but obviously a lot of what we do is still interacting with Modflow, and FlowPy is a pretty handy way to do that from the scripts. Have you guys got anything on that one?
Well, I was just going to add, if you've been following FlowPy in the last couple of weeks, there's been a lot of discussion about making the FlowPy run utility more operating system agnostic and not be so strict about where it finds the executable for these things. And that's a large reason why we have OS utils run, because that Modflow, the FlowPy side of things was really strict about wanting you to add the .exe extension or the ./ if you were using a local binary on Linux. And so the OS utils run inside of PyEmu does all that stuff for you programmatically when it detects your operating system. And so it seems like FlowPy is also moving that way now. So maybe in the future there won't be a big difference. But for me, that OS utils run is a nice way to write a script on Mac, and yet it'll go run on Windows and it'll go run on Linux. And so you guys are benefiting from that in the notebooks as well, and that you can run these notebooks on any operating system because of those types of utilities.
One more question so far from Vincent, which we'll probably come to a little bit as we have a quick look at the homework from last week. But it's a good question. Do you use the 3 levels of parameters, the coarseness, so constant, pilot point, and grid, as standard in your project? Or is this just to demonstrate the range? A bit of both.
Yeah.
I pretty commonly use constant and grid. And I know, Jeremy, you quite keen on the pilot point addition as well to that.
Yeah.
But yeah, if I can, I like to be able to express those different parameters, scales, to represent the uncertainty that exists and may be different at different scales. Yeah. You guys got any more?
I find having that level of flexibility during history matching has been quite powerful since I've started using it. Just a side note, which we might get into later, I'm not sure. The grid scale stuff you can do if you're using a structured grid in PyMU, but not if you're using unstructured grids. Sorry. But that might change with Jeremy's PyPest utils stuff. Not sure.
Yeah. And for me, I like those 3 scales, but not only for the flexibility, but it also ends up being a pretty nice diagnostic that if you see certain types of parameters moving, like if the constant for conductivity is going to the lower bound on every run, maybe that means there's like a unit conversion error somewhere in your inputs, right? You wouldn't expect the mean of the entire field to go completely to the lower bound unless there's something really drastic happening. And so I use it also as a diagnostic to check and see what the information is flowing to those 3 different scales in the ways that I would have expected it to during history matching.
There's a bit more to Vincent's question, but hopefully we might cover some of it off. But just at the end there, can we leave the parameter geostruct undefined? Yeah, so that argument is optional. If you don't define the geostructure when you add parameters, they're just you're not defining any correlation between those parameters that you're setting up. So they're just independent, diagonal, and the covariance matrix.
That's it.
Yeah, it's pretty challenging to cover off all of the ways that we might want to correlate parameters. So there's a few tricks in that notebook, in that Pest from setup notebook, that kind of gives us a bit of an indication of how you can do spatial parameters and correlating spatial parameters, but then also with multiple calls by using the parameter group and that date time argument, you can correlate parameters across multiple calls of that add parameter function. It is a bit of a headache to get your head around, but the critical things are parameter groups, that geostruct argument, and a date time argument, and that allows us to do that temporal correlation. On that, should we review the homework from last week?
I think so.
So I've done my homework this morning, or at least part of it, and I'll share one of my screens. This guy. I've just run to the point at which we ran that pest, which we made that pest pp glm call. So really, it's just the control file setup. So I thought I'd just quickly have a look at what we did in all of this. There's a lot going on, and I'm not going to cover it all. And I think that's the opportunity. If there's something not clear, then people can throw some questions out there. But I just thought I'd kind of show us where we've got to at the end of, well, at this point where just before we run the model. So the main thing, the whole purpose of doing all of this is that we have this pest control file. So and you'll notice that the pest control file isn't necessarily what you're used to looking at if you've been working with pure pest. And this is Jeremy's version 2 pest control file. Can everyone see that, shall I? Is that all?
Yep.
I don't know if I can zoom in on this. So yeah, massively simplified control file, but it means that everything's offloaded. And you can, with PyMu, you can specify version 1 if you want. And that's can be a little slower, but it means that everything's in one file and you should be able to run with pest. So we're offloading a lot of these big tabular components of the pest control file into these external files. So if we have a look at parameter data, it should be not opening in numbers. Come on. It should be looking something a bit like this. So we got our parameter name first up, and then we have all of the stuff that anyone who's run pest will be familiar with a few additional bits and pieces that we're supporting in Pest++. And this is all that metadata that's scraped from the setup. And this is really, really useful for like doing any further processing your parameters. You can store locations, specifically locations on there, or the I and J position within the model grid, or the X and Y. So this is scraped from that add parameters call into the parameter name, and then eventually we can actually store it. And similarly with that observation data from all of those add observation data calls, and again similar looking, and then we have all of this, all of these additional bits of metadata.
Hey, B, Tariq is asking a question.
Yep.
About observation names.
Yeah.
I don't think there is anything explicit about the naming structure, is there? So,
no.
Tariq, can you give us an example of what you're asking about?
There is, I mean, if you have like underscores and stuff like that, then it'll split all of that into metadata, will it not? When you do the add obs.
Yeah, so there's a metadata parsing routine in there, and it expects like the key values to be separated by a colon, and then each chunk of key value pairs to be separated by an underscore. So if you use that scheme, then PyMu can pretty easily put those into extra columns whenever it loads the pest control file for you. So it'll fill out those extra columns in observation data. But other than that, there's nothing explicit about the names that are created.
Yeah, and I think that's a good thing to think about as you are setting up that observation base name. Is if you avoid underscores, it's going to make it a lot easier to do that automatic splitting of the metadata. So if you avoid underscores within strings that you don't want to be split, then it makes the metadata like a lot easier to scrape out. So avoiding underscores and colons unless you want the splitting to occur. So there's a function within the PyEmu load, loading the pest file, which will split on first. It'll split on underscores, and that gives you your column and value pairs, and then it'll split on colons, and then you end up with things like oname columns and otype columns in here, and then use cols will be this, and then time will be this guy, and there are some others in there that have these also as underscore colon components in that observation name. And you can, if you're working in original pest, you can set long names false, or if you're running out of memory, that's another thing. You can set long names false, and what we'll do is PyEmu will create a mapping file that still allows you to load in that metadata at load time, but the actual pest control file observation names will be just O and then a number. So the main thing that we produced through that whole big long script was this pest control file and these separate files. We also constructed all of our instructions files for reading those simulated output files, and all of our template files for assigning parameters. And the other big thing that we've done is how we were talking before about these different scales of parameters, using a multiplier style parameter, which isn't the only option. You can use the classic direct option, but using the multiplier, this does not look like our model input file. Our template files don't look like our model input files, and that's nothing to be alarmed by. So what happens at runtime is that these get connected to these multiplier files, and then there's a PyEmu function that runs at runtime that basically multiplies out the right values from the mult directory with the org directory, and then creates those model input files. And there's actually, I think I've got it in here, Mike Phelan's got a cool little GIF that him and Katie put together that helped describe some of that. So this isn't in your version. This is, Mike's done this recently, but we can forward around this GIF if people want to. People are confused by that process that's happening at runtime.
Are there any questions about the multiplier process beyond what we've already discussed? Anybody have anything else they'd like to add?
Tariq's asking if multipliers are a better approach than direct for all parameters.
That's a good question. You know, I mean, for me, I guess if it's some sort of model update of an existing model and somebody, including stakeholders and regulators, are invested in the existing model input structure, like they really like the hydraulic conductivity array that they've developed over all these years, the multiplier process lets you keep that as sort of the mean of your prior and just sample around that sort of input that everybody already likes. And so, I mean, it's good for consensus building and keeping people happy with you as a modeler. But in terms of, are they better than the direct approach? I don't know. Maybe. I mean, maybe for pilot points, it's nice, right? Because then you can have your pilot point values be ones everywhere, and you can still maintain the structure of that underlying file, however it looks. Otherwise, you have to sort of sample the model cell that the pilot point is in to get the initial pilot point value, and you can maybe lose some of that structure.
Yeah. Yeah, I like the flexibility that the multipliers afford, in terms of those different layers and having different scales of parameter applying to the model parameters. But yeah, I don't know if there's anything that says they're definitively always better. I'll be interested if someone does have an example of where they may not be.
I mean, I've thought for a while that maybe there's like numerical properties of using multipliers in the solution process that's nice, right? Since all the parameter values are of the same magnitude and scale, that maybe that would also help with solving the inverse problem. But I haven't ever actually investigated that any further than just the thought experiment of it.
They do add an extra level of complexity in terms of how to post-process and then display the outcomes to your stakeholders, but that's a surmountable problem.
So the other big thing that we created in that workflow is our forward run script. So if I open him up as well, ended up being a pretty heavy. So this is what gets called in by pest at runtime. So we're not just calling the model, we're calling this whole script, which does all of our work for us. And there's a few steps in the notebook where we added external functions, and they just get dumped in here. A really important thing to note, if you're using packages that are not essentially not in this core group of packages up here, then you'll need to make sure that they in the where the function is defined, that they are up top. So for example, we've got make sure we've got it in here because when it comes to forward runtime, you need to make sure that those packages are available. So that's a pretty important gotcha that I hit all the time. So I have a lot of times when I'm calling these different functions, but I might also be calling them in my model construction normal script, which has a lot more imports at the top of the file or whatever, and suddenly it gets to, I fire off 200 realizations to the cloud somewhere, and they all just fail. So really important to just if you're writing these functions for use, not just at forward runtime, but in your normal processing, to make sure that you've got all the imports that you need that aren't in this, really that aren't pandas, numpy, MP or OS, that they are defined at the head of the function. That will catch you out. And then there's a whole load of automatic removal of the simulated output files, the model output files. So any file that we've passed to add observations sits in here and we attempt to remove it at runtime, so we're not running the risk of bringing in spurious results from a previous run. And you can there are functions within PyEmu to add more files to this list. You can just append to that list, and it'll add another section of try and accept.
Which is important if you're doing post-processing of observations afterwards that rely on a direct model output.
Yeah. I mean, in general, anybody who's used Pest has been burned by this problem, right? Where modflow failed to run, but some existing output files persisted, and then the instruction files processed normally, and then you get results back and there's zero gradient, or you get zeros in your Jacobian, and that's because of these sort of leftover stale files keep getting read, and Pest keeps running, and it can be a logical nightmare to sort out if you don't get rid of these temporary files. So I would encourage everyone to be very diligent with getting rid of temporary files.
Yeah. Wes, thank you, Wes. Wes just pointed out in the Q&A another approach to putting those extra imports in there. So you can just append to this list within that pest from object, and it will add it to the top of the script, which works. Doesn't work for anything that you might have import as or import from. For that, yeah, just be prepared to catch that one. So we come all the way down here after all of that, and then this is actually where things start. So when we were talking about the multipliers, this is the step that PyEmu and PestFrom inserts into the forward run script for you to apply those multipliers. And even if you're using purely direct multipliers, because we wanted to keep as much of the back end as consistent and general as possible, that line will still be in there. It's just all your multipliers will be 1. So even if you're using direct parse, you'll still see that step, and you'll still see these mult in all directories. So you don't necessarily need to freak out that you've done something wrong. So that step will still happen. It will just be ones that get applied. So, and this line uses this info file that was created in that pest from setup, which has a whole lot of information around the formatting of the files, the model, where the original file is with your original values, where the model file is that will get read by the model when you execute it, and then some of the formatting, where the multiplier file is, and this is the bit. This is kind of where all of that knowledge is stored to apply those multipliers at runtime. So it's a pretty important file. Probably not one you want to go manually editing afterwards. And then finally, we run the model, we run the secondary model, and then we run those post-processing scripts. And we should, if everything lines up nicely, if I go up here and I haven't broken anything, with not max 0, this will just run the parval1 in the pest control file. Not max 0. And hopefully runs the model once, and you get all of these errors because those original simulated outputs, those files that aren't in there, so you get some of these little errors, but that's nothing to worry about because they shouldn't be there. That's that try except routine working, and then we should end up with a whole load of zeros. And this is because when we set up those observations into the obsval column in the pest control file, we are just dumping the previous simulated value. So provided nothing's changed with your parameters, the executable that you're calling, or actually that's pretty much it. There's just those two things, or your post-processing, you should always see a 5.0 at the output of that obsval not max 0 run. So there we go, confirming. And it's a really good sanity check to have in there, because the amount of times you see a number that other than 0 in there, and it normally means that something's broken with how your parameters are set up, or more likely how you're scraping those outputs, and whether those outputs are actually in the right place or misaligned, or occasionally you're running a different version of ModFlow and you get a different result, and that's not our fault. Was there anything else we wanted to cover there? Any questions on that stuff?
Is it worth going into a bit of the bounds of the multipliers in terms of how they?
Yeah, I was going to say, when Briok showed that multi-model info CSV, I thought back to Tariq's issue about multipliers. And so the one thing that multipliers will get you in trouble with is actually enforcing plausible bounds on the resulting model input array. So if you have all these multipliers working together, you can pretty quickly generate some extreme values if you end up with a low constant and a low pilot point and a low grid value. And so that's why there's that ultimate bound option that's inside of add parameters. And so that's the upper and lower bound you're seeing in this file. That's not the pest control file bound. That's the actual bound that gets enforced on the resulting model input file before it gets saved, after all the multipliers are applied to it.
Yeah. So porosity is a big one there. You don't generally want porosity to go too close or over 1. So that's normally one that you want to slap that ultimate upper bound. But yeah, keeping track of things like that. So how extreme how non-physical could things go? I guess theoretically you don't want to be going past those bounds too often within your ensemble, within your realizations. but it is good to have a little bit of a control on physical sense. So that's in, so let's see if I can find an example in here. So the upper and lower bounds specified in here, in the add parameters call, they are the upper and lower bounds as far as test is concerned. And then these alt L bound, alt U bound are those ultimate bounds on the model inputs after all the parameters have been applied. So these ones are on those multipliers, and these ones are on those model input values, which is why they're so peculiarly different. And when we come to drawing, using the Pestron methods to draw your ensemble, it is these upper and lower bounds that provide us an indication and provide PyMU an indication of what the standard deviation of that parameter should be. So that's your diagonal on that covariance matrix is provided by these. And I think our default for, it always catches me out, for PyMU is that these bounds represent 3 sigma, 3 standard deviation either side of your mean, and your mean value is whatever value is in the file that's scraped out into that parval1. Or actually, sorry, for multipliers, your mean value is 1. And for additive type parameters, which is another option, which I'm not sure we have in this example, but they're in there somewhere.
I think you're looking at them right now, man.
Oh yeah, oh yeah, look at that, parstyle A. Yeah, so then the oh yeah, so the lower bound is negative, and then that initial value will be 0. So we're going +2, -2, representing a total of 6 sigma from either side of 0, or 3 sigma either side of 0, 6 in total. That was clear as mud, wasn't it? We got questions from Cecile and another from Tarek. So Cecile, you mentioned there is a function to remove extra files in the forward run. What is it called? Ah, damn it.
I was looking too. I think it's like
don't test my
TMP
memory.
files. It's a list, isn't it?
It's a list, and we just append a file name to that list.
I'll find it just a second.
Jeremy will find it. And another one from Tariq. Can I pass in a cove made by PP Cove SVA for pilot points in PyMU? Rui's nodding his head. Do you want to be more committal?
It's a bit of, requires a bit of faffing around with making sure that parameter names are in the right order and things like that. But yeah, you can pass in the covariance matrix fine, and just need to make sure that everything is aligned in the matrix in terms of the same parameter names and stuff like that. And because there's several different ways in which the ppcov writes covariance matrices, if I remember correctly, in terms of if it stores parameter names and things like that, just be aware that you might need to process them. So there's no one standard way to process them. Just be careful in terms of how you're reading them in and make sure they line up. But again, with Jeremy's new PyPest utils, that becomes old news.
Well, so that all that ppcov SVA stuff is in PyPest utils also, so you can make them that. So Tariq, are you passing that covariance matrix in to draw from it, or are you using it for like prior regularization? I'm just curious how you're using that covariance matrix.
Whilst Tariq replies. So the way I've done it in the past when working with ppcov SVA is I'll actually generate the prior covariance matrix as a diagonal, and then I'll splice in those ppcov SVA matrices into that, not actually passing it in during construction of Pestrom or anything like that. Let's see, he's commented below. Drawing mostly is what Tariq says.
Ah, okay.
There's a question from Matteo on temporal correlation. Temporal correlation. Outside of sort of the group of people here, I've never seen it applied, to be honest. You guys?
I mean, I've been more excited about it on the observation noise side lately than I have been on the parameter side. So I tend to be getting excited about having correlated noise realizations more than having correlated temporal parameters. But I mean, if you have like a recharge parameter that varies every stress period, and your stress periods are short, like days, you want to put some sort of temporal correlation on those. Otherwise, you get sort of the stair stepping of wildly varying recharges day to day. And maybe that's not really what you want. Maybe you want recharges that vary high seasonally or monthly rather than, daily. So that's what that temporal correlation would do for you, is make sure that your realizations of recharge every day aren't changing wildly from day to day. They have some structure in there.
I think I've to be honest, I haven't even thought about not doing it, where I've had the feeling that there would be reasonable correlation between, like temporal correlation between parameters. I have done some pretty disgusting things, like correlating like January recharges or January stream inflows across multiple years with a long range, and then you can do the same thing. I think you can have multiple temporal scale parameters applying with different correlations. So you could have like a wet season and a dry season parameters that are barely correlated, but then you can correlate all the wet season parameters over 10 years, 20 years, whatever. So you can get pretty creative and find yourself pretty deep in a correlation rabbit hole with these sorts of parameterization schemes.
Another interesting question, which I haven't got a good solution to, but approaches to maintaining relationships between parameter fields like KH and KV. Do you have any?
Well, I mean, I tend to do the KV as a ratio of KH just to make sure I don't get myself into sort of embarrassment mode with people where KV is much higher than KH. But for the ones that are like maybe between zones where you want this zone to be higher than that zone, I mean, you're almost going to have to enforce that as some sort of observation after the model runs, at least in the ensemble sense. If you're doing just a single set of parameters, you can maybe set up regularization to do that for you. But if you're in an ensemble setting, enforcing every realization to have different but yet statistically coherent differences between different parameter types, I think it has to be done in the observations.
What about things like correlations between specific yield and conductivity, things like that?
Yeah, exactly. Yeah, exactly. So I mean, you would have to have some sort of relationship that says, if K is high, porosity has to be at least this high. Like some sort of loose function with maybe an inequality type of approach to keep it in that range of plausibility.
I guess that's so using, you would then have to get pretty bespoke about your covariance matrix. So we're pretty much just sitting in that block diagonal covariance space for both setting up your parameter uncertainties and the covariance of them, but also the groups are used in that draw. So you'd have seen, oh, actually, we're on that bit now. So if we look at this covariance matrix, we've just got this huge block diagonal with all of these block diagonals in there. So these are probably our grid scale parameters, and then we've got some more that are really close to the diagonal. But then when we do this draw step, you'll see that we actually make use of the fact that we can break it down into these group-wise chunks, and that makes the draw a lot more efficient. So the draw of those realizations is a lot more efficient, and we can use some cheeky cheating steps like SpecSim to rapidly generate those realizations. So I think it's definitely doable, but you'd have to be able to get pretty bespoke and granular about defining that covariance matrix, and then make sure it's not too big to sample.
Well, and even then, I mean, anytime you start adding off-diagonal elements to any matrix, like you got to be really careful what you're doing, because you can really quickly make it so that you can't invert that matrix to draw from it any longer. So, I mean, if there are things like the relationship between conductivity and specific yield or porosity, I almost always try to enforce those as observation penalties rather than sort of bake those into my prior realizations.
I know a particular Wes Kitlaston who's got some obsessions around K and porosity needing to be correlated. Sorry, Wes.
Are those political correlations or scientific correlations?
I'm not sure. I've tried. We talk him out of it.
Okay, good.
Sorry, Wes. That'll be Wes responding, is it? Yeah. Okay. So shall I leave it there with that run through? And we can get on to some of the stuff you wanted to talk about, Jeremy. I think I've blabbed on too much.
You pretty much covered the bits that I was hoping to talk about. I mean, I was just going to open the rec file, but that's exceedingly boring. So maybe I won't do that to everybody since it's already 45 minutes in. No, do we have any more questions about the PEST interface that we've set up? Anybody want to discuss any additional bits? Okay. Awesome. It's been a pretty good discussion so far, I think. So what was next? I think we were gonna, let's see, talk about sort of where we are in our workflow, right? So we've wrapped our Freiberg model with a pretty comprehensive PEST interface. We've also, as part of that process, generated a prior parameter ensemble. So we've got that big piece checked off, but we have not defined the likelihood function, right? The observed values in that PEST control file are just the original model outputs that we scraped in and read, and all the weights, I think, are just ones right now. Like there's nothing to do with weights that have been defined. So we haven't defined what we would call the likelihood function or the objective function yet. And we haven't run the prior parameter ensemble. So next week's big steps will be running the notebook that imports what would be an observation data set. It processes it a little bit and samples it and assigns it to those quantities in that observation data frame that's in the pest control file. And we also do some work with the weight balancing and defining weights and noises that will get used later on in the following analyses. So that's one notebook next week. And then the other notebook next week, we're actually going to fire this thing up and do some parallel runs. We're going to do what I think is a pretty fundamental and very easy analysis, which is just run the prior parameter ensemble. So we're not going to try to adjust parameters or optimize anything. We're just going to run all those geostatistical realizations we generated through the model, capture all the different outputs that we set up as observations, and quit. And man, I'm really a big fan of prior Monte Carlo these days for diagnostic checking and understanding how your model's performing, not just with one run, but statistically across the range of possible values. And so those will be the two notebooks for next week. But to do that, we're actually going to have to do some parallel, we don't have to do it, but we're going to do some parallel model runs to make that prior ensemble evaluation go faster. And so for the first time, we're actually going to try to melt everyone's laptops between now and next Friday. So what's going to happen is in that prior Monte Carlo notebook, we're going to spawn a master directory from our template directory, and that's where the master instance is going to be living. And then we're going to spawn off below that a bunch of worker directories. And every one of those workers is just going to connect to the master and get parameter sets to run. It's going to run those through that whole forward run process that Briok showed and process the instructions, and it's going to send back the resulting simulated outputs. And so I think Rui was going to demo, you still want to do that, Rui? What it's like to start, just to show you guys what the parallelization process looks like under the hood, because we're going to use a PyMU helper that does just some file manipulations of copying directory, going into a directory, starting a process, coming back out of that directory, and repeating that a bunch of different times to get the workers going for you, so you don't have to manually copy and paste. You okay to do that still, Rui?
Yeah, it'd be super interesting for everyone to watch me copy and paste stuff, but yeah, we can do that.
Well, should we take a poll? Does anybody want to see Rui do this, or is everybody good with the parallelization stuff?
Or the other way around, does anyone need?
Vincent has his hand up. Is he saying he wants to see it, or he doesn't want to see it?
I think so.
What does he want to talk?
That was Julius Caesar thumbs up, I think.
Oh, okay, got it.
Hey, I'm wearing my parallel running
Check
with
that out. So Tariq has a very interesting question. What if I want to launch across multiple computers? So if you want to go across multiple computers, you need something that can talk across multiple computers. And so I think I'm a big fan of HT Condor, which is what Briok uses, and I've used extensively in the past, and we're trying to get it working here in the Perth office, but Antera has a Linux cluster in Austin that uses HT Condor. And so I think that's what most people use to coordinate across. If you have 10 or 15 other computers, if you just have like 2 or 3 other computers, you can go onto each one of those computers and do that PyMU start workers command and just pass it a special sneaky IP address through one of the arguments, and it'll start all those workers and tell them to connect across the network to where the master is running. So I mean, and that's a little bit cumbersome, but if you just have a couple computers, that's not so bad. But if you have more than, say, 2 or 3, HT Condor is the way to go. Like I said, that H, I'm working on my Australian H. Yeah,
okay, so
that's HT Condor. Super easy to install. There's a Windows installer, Linux installer. Just sort of click yes, yes, yes for most systems.
If you get stuck, message Mike Feenan.
Yeah, if you get stuck, Dr. Feenan can help. That's right.
As long as it's not Windows, right?
Yeah,
that's true.
Well, he can still help. He'll tell you to convert to Linux.
All right. Okay, so I'll just share my screen. Hopefully you guys can see all of this really interesting stuff. So I've just got a one of those model folders that we set up in one of the tutorials in a new folder here, just so that we can run through deploying it with pest. And I've got it set up with basically a prior Monte Carlo run, just as you'll do in your next week's homework. And because I never do this, I actually have the pest++ documentation open next on this page on the right, so that I can remember all the commands, because I never can. So the way that running pest in parallel works is that you'll have one instance of pest++, whatever type it is, running as a manager, and then a whole bunch of other instances running as agents. The manager manages the whole process, sends information or sends jobs to each of the agents, and then collects the information from those agents and keeps updating the runs. And all the agents are really doing are running the model, collecting, assigning the parameters, running the model, collecting the observations, and then sending the collated information back to the manager. Each of these instances should be in its own folder so that you're not reading and writing so that each instance of PES++ is not reading and writing the same set of files, so they each need to be separate. So what this means is a whole bunch of copies of your model folder. So just so you know what I'm talking about, this is the model directory that we're already familiar with, as all of our model files, template files, instruction files, etc., etc. And because I'm pedantic and like to keep everything separate, I make a copy of this, and I'm going to make this folder my master. Now, I've got a command line open here already, because I'm going to be running the pest control file that has that forward run.py, requires that I have all my conda environment, etc. So just make sure that you're running it with your conda environment active, at least in Windows. I'm not so sure how Mac and Linux handle that. So I can just go into that. And then I'm going to deploy my master by running this command. And so in this case, I want to run case. So case is the pest control file name, essentially. And in this case, I called it pest pp prior, I think it was. So that has my pest control file name. And the /h does something, which I don't remember what it is, but it's instructing pest to work in a certain manner. Then the important part here is defining the port number. Now, you need to make sure that this port number is open. Rule of thumb 4004 it usually is. Just something to keep in mind that if you're running multiple instances of your master on the same machine, don't use that same number. Otherwise, you'll have bad times.
Very bad times.
Okay, and I hit enter or return, and there we go. Master is deployed, super fast, Freiburg, and there's not much to do. And well, what we see here in the command line is that the master is waiting for a whole bunch of agents. So there's no agents running, waiting, or uploading. So that's the master is deployed, and it's just sitting there listening on port 4004 until it hears an agent. So to make an agent, I need to make another copy of that folder, and now I'm going to call that agent 1. And I'm going to have to open another command line because I'm a noob. And I'm going to just do that to be quickly, switch into that, activate my conda environment. And now this time, I'm going to have to write this string. So this is how we deploy the agent. So the first part is the same, so pest pp AUS, and then the pest control files. So this is Freiburg pp prior.pst, and again /h. Now the text string here that we need to put is the host name. So the location of where that, or the machine on which that on which the master is running. Because I'm running on the same machine, I can just use localhost. If it were running somewhere on my network or on the cloud, then I would have to have either the IP or the host name of that machine. And I need to specify the port, and so it needs to be the same port as the master is running on. So we can see all of that there. I'm just going to hit return, and boom, you can see the agent starts doing stuff, and you see the pest starts to run, runs the model, and you can see that happening iteratively. If you switch back here to the master's control terminal, then you can see we now have one agent running. And so that's great and all, but we don't want just one agent, we want multiple. And I'm not going to bore you with repeating that process all over again. But for every agent that you'd want to be running, you'd have to copy paste, deploy, blah, 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 blah. And if we just want to look at my CPU usage, so just from one agent, we can see that there's a bit of CPU usage, but far from the total. Rule of thumb with Modflow, because it's using a single core, we tend to use at most the number of cores that we'd have on a machine. Sometimes a bit less, depending on what you're doing. So for my case, for example, I'd probably deploy around 12, 16. So 16 agents on this machine, and that would block out my machine and I wouldn't be able to do much else. Now, that's really fun, but we live in the Python world and we've got better things to do than copy pasting folders. So what we do is, and you'll see this function in all of those tutorial notebooks, is we just call this PyEmu method, which deploys the workers for us. And so what that will do is essentially all of the steps that I just did by hand, but in one go. And so I'm just going to demo that here. And let's get crazy and see if I can break my machine on live on air. With 10, I'll be fine. So if I go back up into my folder, and then I'm just going to call this script file here, which I have open on the right-hand side. All it does is it calls this function by okay, the core parts of this function is I tell it where my original pest template folder is, and that's this Freiburg MF6, which you just watched me copy paste a bunch of times. I tell it which version of pest I wanted to call, or what that start workers is going to call on the command line, the pest control file, how many agents I want to deploy, where I want to deploy those agents. And that can be useful, especially if you're using things like RAM disks or things like that speed up a lot of this process. And the location of my master directory. So that's where my master process will be running and where all my results will be compiled at the end of the pest run. Okay, cool. So to do that, what did I call it? Run. Well, spelled wrong. Pest.py, and boom. And what will that do? So it deploys your agent. You can, and immediately you see all of my. Ooh, did I forget to hit save? I don't. Whole bunch of agents start running. How come it only ran 4?
Control S.
Should be 10. Control S. What does that do?
You probably didn't say. You probably didn't save.
Yeah, let's try that again. Okay, boom. So Control C stops everything. That's weird. It's a different folder. That's because I'm using the wrong file, dumbass. Okay, doesn't matter. Let's just leave it at that. So you can see that the master was deployed in this folder. And if you go into that, you'll see all of the same files that we've been watching. And as this goes, it'll start writing new files. So the pest observations and parameter files get recorded there. And PyEmu deployed a whole bunch of workers, in this case, only 4. And again, if I move into there, you can see the model. The model is being run, parameters updated, observations being recorded, blah, blah, blah. And that's it, I think. Anything I've missed?
Just, I would say that I obsess. Once I've got something running, I'm just obsessively staring at the RMR and the rec files.
Good point. Yeah.
Just to make sure that things are running.
Yeah, and it's a good way to catch when you've made a mistake somewhere along the line. I usually have a little script that will be checking things and just popping out plots that are useful. One thing to note is that deploying pest in this manner is you can see the master in the terminal, but you can't see the agents. So if your agents are failing, or if there's some warning message that ideally you actually need to be seeing, you can't see it. So if you want to go and do some troubleshooting, then you might actually have to manually deploy an agent in a different terminal just so you can see what's happening. And that's one limitation of doing this. Yeah, that's all I think. And there we do. There we got it. 1 minute to do those 4 agents for Ireland. All right. Cool.
We're past the hour, but we do have a few questions.
Yeah.
Do we, if people are, this, I mean, this is recorded, so people don't feel like they have to hang on.
Yeah.
should we address them while we're here?
Yeah, I think so. If that's all right with you guys.
So Tariq has a good point for some, those that enjoy hardware discussions. The new Intel CPU cores have efficiency cores that are not supposed to be used for high intensity CPU workloads. So we check in those notebooks with one of those PSUtils functions, I think, isn't it? So it checks your logical process, but may not give you the correct answer for the new Intel efficiency cores. I think that's good information, Tariq. I don't know. I don't know what to do with it. Or whether it's yeah, I think it is probably worth thinking about that if you're running those computers. You don't have to use the automatic checking one. On my computer, I just set it to 8 or 10 and be done with it. But no, that is a good point. So Chris, halfway through a PES run and would like to terminate PES and get PES to output the current run.
Yeah.
Par file, obs file, etc. Is there a way?
I assume Chris is talking about like you're doing like an IES kind of thing, like you're running an ensemble and you want it to stop waiting on the remaining runs to finish. Is that right, Chris? Maybe. So I'll assume that's the case. Okay, yeah, sure, that's it. Okay, cool. So the not latest versions, for like the past year or so, you can use a pes.stp file, like the pes stop file. If you put that in the master directory and you put a 4 on the first position of the first line of that file and hit save, IS should almost instantly detect that, fail all the remaining runs, and then write the runs that did finish to files and quit. So if you're sitting there and you're waiting for like 2 runs to finish and it's been days, you can use that pes stop file to have it quit waiting on those 2 runs, fail them, and then go ahead and save files. And I'll put a link to that in the chat.
Nice. Wes says, do you gain or lose anything by using num workers equals logical processes versus physical causes? Similar question, I think. Does the same hold for num threads in the process that are multi-threaded in PEST PP? Yeah, that's a good point, Wes. So there are there are parts of the forward run that are threaded as well, or multi-processing as well. So the applying of the multipliers might be, and there are parts of the PES PP writing, I think, is it? There are parts in that PES++ that are multi-process.
You can try to turn on some threading in the IS solution process, but it's not super efficient. So, yeah. I mean, generally for me as a rule, I try to leave one core free if it's not a quick synthetic model like Freiburg. Like with Freiburg, you can get away with overclocking and using lots of workers. But if you're getting into a model that's actually going to be solving equations, like solving mod flow equations, heavy duty, lots of iterations, lots of stress periods, I try to leave one core free because it seems like if I get too aggressive with that, the runtime of the whole thing just it explodes, right? And it takes a lot longer for even one run to finish. So and maybe that's outdated information, but that seems to be the way I've done it in the past, was try to leave one free.
I guess normally we would hope that we, between like individual realizations, finish at different times so that they're not all firing up multiple threads at the same time. But if you had a very consistent run, or I guess if sometimes that first one, they could be firing up some processes all at the same time. So having a little bit of headroom. And most computers now will partition tasks to whatever part of a core is available. They're pretty fluid. But yeah, you do probably want to leave a little bit of headroom. The other thing with things like mod flows, they can be quite disk heavy as well. So if you have a whole load of realizations that are finishing at the same time and trying to access the disk, or even just riding like incremental buffers, then things can get a bit chewed up. So it is a little bit of case dependency, and people do, I suppose, have to see what works best for them. I've found on occasions that dialing back the number, if I'm running locally, dialing back the number of workers is helpful. I think if you're running on something like HT Condor, where you still might have a lot of simultaneous runs on an individual machine as you're using all the processes of that machine, you can actually stage a delay so that it doesn't fire up all of the jobs at the same time. So you can put in like a little 10-second, 30-second. And if your model's taking 10 minutes to run, then it's not a big deal to have a little buffer. But yeah, you might hit that some of those things as you go. Not so much with the Freiburg demo examples, but once you start pushing the envelope on your own stuff, you will find where things break. Another question: is there a speed difference between running parallel processes from Python or from batch file? Which way is more efficient? Well, Python's rarely more efficient.
Right. I guess the thing is with Python, though, it becomes systematic. If your forward run call is a Python script, then you can go between Windows and Linux and Mac with the same workflow. But if your forward run is a batch, you're kind of locked to Windows. And then you'd have to write a shell script that replicates what's in the batch file if you wanted to go to a different OS. But I reckon the batch probably is faster because it's closer to the metal than having to start Python, especially if it's a really fast model, you would notice that difference. But if it's a model that takes 20 minutes, 30 minutes, I don't think you'll see I don't think you would notice the difference between a batch and a Python script.
I have noticed differences in the multiprocessing in Python between Mac and Linux and Windows. So the Windows tends to be a bit of a bottleneck for that multiprocessing, and it's to do, I think, with how it handles memory and forking of processes and memory. I'm sure there's some adept computer scientists online that would probably explain it to me, but yeah, it is. What I've noticed is that Windows can be a lot slower for some of those tasks.
Sweet. Well, I think that's it. So just to reiterate, for next week, we're looking at doing, let's see, it's called part 2, number 2, obs and weights, and part 2, number 3, prior Monte Carlo. So those 2 notebooks. I think it was a pretty good discussion today. I appreciate everybody's questions and answers. And so if we can continue that next week, that would be fantastic. And otherwise, we will see you guys next Friday.
Cool.
Great stuff.
See y'all.
Take care all. Bye.
Cheers.